Good morning, morning student. Dr. Dharmendra B N. Today I will discuss about nth derivative of standard function. So this one is for first BSc Mathematics, University of Mysuru. The session is 30. So we know that's in the differential calculus one, that is nth order derivative of standard functions. Recap the definition of derivatives and example how to find the successive derivative. Learning objects to find the nth derivative by using successive derivative. The session outcome how to find the nth derivative of some standard functions. Requirements terms is differentiation of standard functions. So we can take the nth order derivative of x to the power of m. So again, to find the nth order derivative of x to the power of m, where m is a positive integer, let y is equal to x to the power of m. Differentiating this equation with respect to x, that is y1 is equal to m into x to the power of m minus 1. Once again, we have to differentiating this one, that is y2 is equal to m into m minus 1 into x to the power of m minus 2. Again, when I have to differentiating with respect to x in this equation, that is y3 is equal to m into m minus 1 into m minus 2 into x to the power of m minus 3. So, in generally terms can be written as, that is yn is equal to m into m minus 1 into m minus 2 up to the terms of m minus n plus 1. That is m minus of n minus 1, that is when I have to multiply the terms of minus, that is m minus n plus 1 into x to the power of m minus n. Or it can be written as the terms of, when I have to multiply the terms of both numerator and denominator, multiplying and dividing throughout by m minus 1 into m minus n minus 1 up to terms of 3, 2, 1 in both numerator and denominator into x to the power of m minus n. So it can be rewritten as the terms of m factorial divided by m minus n factorial into x to the power of m minus n if n is less than m. This is the terms. Note the terms of if y is equal to x to the power of m, where m is a positive integer, and if n is less than m, then it can be written as yn is equal to, that is nth order derivative of x to the power of m is equal to m factorial divided by m minus n factorial into x to the power of m minus n. Suppose the terms of if m is positive integer and if both m is equal to n, then it can be written as the terms of x to the power of m minus m, that is equal to 0, x anything to the power of 0, that is 1, the terms here. Here also the term of m factorial or the terms of m n factorial divided by m minus m, the terms is 0. 0 factorial is 1, so therefore yn is equal to n factorial when n is equal to m. If y is equal to x to the power of m, where m is a positive integer, and that condition is if n is greater than m, so then that nth derivative is equal to 0. So next we can find the nth derivative of ax plus b whole to the power of m, where m is a positive integer and n is less than or equal to m. So what is the given term? The given term is y is equal to ax plus b whole to the power of m. We can call that is equation 1. We can take the derivative with respect to 1. We get, it is a y suffix 1 is equal to m into ax plus b whole to the power of m minus 1. Again we have the derivative the terms of ax plus b, that is a. And differentiating the above equation with respect to x, we get the terms of y2 is equal to m into this derivative, that is m minus 1 into ax plus b whole to the power of m minus 2, and the terms is here once again we have to taking the derivative, that is ax plus b derivative is a into a, that is a square. Again differentiating the above equation with respect to 3, that with respect to x we get the terms of y3 is equal to m into m minus 1, m minus 2. Again we have to take in the derivative, the terms of this one is x plus b whole to the power of m minus 3, and this derivative is a, that is a into a square, that is a cube. More generally, that's nth order derivative by using these types. That is, we can take in the conclusion of the nth term, that's equal to m into m minus 1 into m minus 2 up to m minus of n minus 1. When I have to multiply the terms of minus, that is minus n plus 1 into ax plus b whole to the power of m minus n into a to the power of n. Here also we have to multiply and divide by the term is m minus n into m minus n minus 1 up to 3 to 1, both numerator and denominator. So therefore it can be rewritten as the terms of, that is m factorial, the numerator term is m factorial divided by, and the denominator is m minus n factorial. The remaining term is, that is ax plus b whole to the power of m minus n into a to the power of n if n is less than m. So here also that note is there, if y is equal to x plus b whole to the power of m, where m is a positive integer and n is less than m, then that nth order derivative of x plus b whole to the power of m is, that is m factorial divided by m minus n factorial into ax plus b whole to the power of m minus n into a to the power of n. Here the terms is, suppose if m is equal to n, so therefore the derivative of this one, it can be written as, that is a to the power of n into n factorial. If n is more than m, that value of this derivative, that's equal to 0. If y is equal to x plus b whole to the power of m, where m is a negative integer, we have to put m is equal to minus p in equation 2. It will get the terms of yn is equal to the nth order derivative of ax plus b whole to the power of minus p is equal to minus 1 to the power of n into p plus 1, p plus 2 up to the terms of p plus n minus 1 into x plus b whole to the power of minus p minus n into a power n. Or we have to take some simple manipulation. It can be written here also, we have to multiply throughout by the terms of here, and is p plus the terms is 1 into 2 into up to the term of p minus 1, both numerator and denominator. It can be written as the terms of p plus n minus 1 factorial divided by the terms of p minus 1 factorial. So overall the terms of the derivative of 1 divided by ax plus b whole to the power of p, that nth derivative is minus 1 to the power of n into p plus n minus 1 factorial divided by p minus 1 factorial into ax plus b whole to the power of p plus n into an. So we can take that next one, that is nth derivative of log of ax plus b. We can take the first order derivative, that can be written as y1 is equal to 1 divided by ax plus b into the derivative of ax plus b is, that is a. Now we know that the nth order derivative of 1 divided by ax plus b, that's equal to minus 1 to the power of n into n factorial into a to the power of n divided by ax plus b whole to the power of n plus 1. Now I have to replace n by n minus 1 in this equation, that is n minus 1 derivative of x 1 divided by x plus b is minus 1 to the power of n minus 1 factorial into n minus 1 factorial into a to the power of n minus 1 divided by x plus b whole to the power of n. So we have to take the n minus 1 differentiating in this equation 2 and comparing with the terms of this equation. So therefore the n minus 1th order derivative of y1, that becomes yn. So that it can be rewritten as that n minus 1th order derivative of 1 divided by x plus b into a, that is equal to minus 1 to the power of n minus 1 into n minus 1 factorial into a to the power of n divided by ax plus b whole to the power of n. Similarly, next we can take that find the nth order derivative of e power ax. You know that the given term, that is y is equal to e power ax. We can take the first order derivative of y, that is y1 is equal to e power ax into derivative of ax is, that is a. Again, differentiating the above equation with respect to x, we get y2 is equal to e power ax into a square. And similarly, in terms of a third order derivative, that is y3 is equal to e power ax into a cube. More generally, that is nth order derivative is equal to e power ax into a power n. Next, find the nth order derivative of a power mx. Let the given term y is equal to e to the power of mx, differentiating that above equation with respect to x, we get the first order derivative is equal to a power mx into the derivative of the terms of mx, the terms of, that is m, into the terms of log a, differentiating the above equation with respect to x, that can be written as a power mx derivative is a power mx into log a, the terms is, again we have to take in the derivative of m, that is m square, here log a into log a, that is log a square. Similarly, we have to take that third order derivative of the given function with respect to x. We get, let us say, y3 is equal to a power mx into m cube into log a whole to the power of 3. More generally, there is a nth order derivative of a power mx is equal to a power mx into m to the power of n into log a whole to the power of n. Next, find the nth order derivative of sine of ax plus b. Let y is equal to the given functions, the sine of ax plus b. Differentiating the equation 1 with respect to x, we get y1 is equal to cos of ax plus b. We know that sine of pi by 2 plus theta is cos theta. We are using this method, the terms of cos of ax plus b can be written as in terms of sine, that is a sine of ax plus b plus pi by 2. You can call this one as a first order derivative. Again, we are differentiating the above equation with respect to x, that is y2 is equal to cos of ax plus b plus pi by 2. Here a is there, so again we are differentiating this term with respect to x, so that is a into a square. Again, cos can be written as in terms of sine, that is y2 is equal to a square into sine of ax plus b plus pi by 2 plus pi by 2. So that is 2 into pi by 2, that is a square into sine of ax plus b plus 2 into pi by 2. Similarly, that is a third order derivative is a cube into sine of ax plus b plus 3 pi by 2. So more generally, that is nth order derivative of sine of x plus b is a power n into sine of ax plus b plus n into pi by 2. Similarly, in terms of nth derivative of cos of ax plus b, so we can call this one as given equation as 1. We are differentiating equation 1 with respect to x. y1 is equal to derivative of cos of ax plus b is, that is minus sine of ax plus b into derivative of ax plus b is, that is a. So therefore, once again we know that cos of pi by 2 plus theta, that is minus sine theta. So therefore, here the sine can be written as in terms of cos, that is a into cos of x plus b plus pi by 2. Once again, we have to differentiating the above equation with respect to x, that is y2 is equal to minus sine of ax plus b plus pi by 2. So again, we are differentiating this one with respect to x, that it will get a. Here a is there, here also a is, that is a square. So once again, then sine can be written in terms of cos. We can add that pi by 2 here, that is a square into cos of ax plus b plus pi by 2 plus pi by 2. Therefore y2 is equal to a square into cos of ax plus b plus 2 pi by 2. So similarly, y cube is equal to a cube into cos of x plus b plus 3 pi by 2. So more generally, that is nth order derivative of cos of ax plus b is a to the power of n into cos of ax plus b plus n pi by 2. So next one, find the nth order derivative of e power ax into sine of bx plus c. So we can call this one as equation 1. Differentiating equation 1 with respect to x, we get, here also we have to observe this one as in terms of a product rule, that is y1 is equal to e power ax, derivative of sine is, that is cos of bx plus c into b, plus derivative of e power ax is, that is a into e power ax into sine of bx plus c. So therefore, in the both the terms, e power ax is a common term. You can take it common outside from the two terms, that is e power ax into a into sine of bx plus c plus b into cos of bx plus c. Put a is equal to r cos theta and b is equal to r sin theta, then it can be written as r is equal to square root of a square plus b square and theta is equal to tan inverse of b by a. Therefore y1 is equal to e power ax into a is r cos theta into sin bx plus c and b is r sin theta cos of bx plus c. So therefore in this term you can take r as a common factor, that is r into e power ax, therefore cos theta into sin of bx plus c plus sin theta into cos of bx plus c. So or it can be written as y1 is equal to r into e power ax into sin of bx plus c plus theta. Similarly, in terms of second order derivative, y2 is equal to r square into e power ax into sin of bx plus c plus 2 theta. More generally, that nth order is r to the power of n into e power ax into sin of bx plus c plus n theta, where r is equal to square root of a square plus b square and theta is equal to tan inverse of b by a. Similarly, in terms of find the nth order derivative of e power ax into cos of bx plus c, let y is equal to e power ax into cos of bx plus c. Differentiating the above equation with respect to x, we get y1 is equal to, here we are using the product rule, that is a into e power ax into cos of bx plus c minus the derivative of cos is, that is minus, and the terms of bx plus c derivative is b. So that is minus b into e power ax into sin of bx plus c. We can take e power ax as a common term, that is y1 is equal to e power ax into a into cos of bx plus c minus b into sin of bx plus c. Here also we have to put a is equal to r cos theta and b is equal to r sin theta, then r is equal to square root of a square plus b square and theta is equal to tan inverse of b by a. So I have to substitute these values, that is y1 is equal to e power ax into r into cos theta into cos of bx plus c minus r into sin theta into sin of bx plus c, or the terms is, in both the terms is r is a common term, we can take it outside from the common factor, that is r into e power ax cos theta into cos of bx plus c minus sin theta into sin of bx plus c. That can be written as the terms of cos of bx plus c plus theta, that is the first order derivative is r into e power x into cos of bx plus c plus theta. Similarly, y2 is equal to r square into e power x into cos of bx plus c plus 2 theta. So therefore, more generally, there is a nth order derivative of e power ax into cos bx plus c is equal to r to the power of n into e power ax into cos of bx plus c plus n theta, where r is equal to square root of a square plus b square and theta is equal to tan inverse of b by a. So we have to take the multiple choice question. Find the nth order derivative of 3 to the power of 2x. So therefore, the first option is 2 to the power of n into 3 to the power of 2x into log 3 whole to the power of n. This be option B, 3 to the power of n into 2 to the power of 3x into log 2 whole to the power of n. Option C, 2 to the power of n into 3 to the power of 2x into log 2 whole to the power of n. Option D is none of the above. The answer is 8. Second one, find the nth order derivative of cos hyperbolic square into 2x, that is 1 by 4 into 4 to the power of n into e power minus 4x plus minus 4 whole to the power of n into e power 4x. Option B, 1 by 4 into 4 to the power of n into e power 4x minus 4 whole to the power of n into e power minus 4x. 1 by 4 times 4 to the power of n into e power 4x plus minus 4 to the power of n into e power minus 4x. Answer option D is none of the above. That means the answer is C. The next multiple choice question is find the nth derivative of sin square x. 2 to the power of n minus 1, option A, 2 to the power of n minus 1 into cos of 2x plus n pi by 2. Option B, minus 2 to the power of n minus 1 into cos of 2x plus n pi by 2. And option C, minus 2 to the power of n minus 1 into sine of 2x plus n into pi by 2. Option D is none of the above. So answer is B. Next one, find the nth order derivative of log of 2x minus 1. Option A, minus 1 to the power of n into n factorial into 2 to the power of n divided by 2x minus 1 whole to the power of n. Option B, it's minus 1 to the power of n minus 1 into n minus 1 factorial into 2 to the power of n divided by 2x minus 1 whole to the power of n. Option C, minus 1 to the power of n minus 1 into n minus 1 factorial into 2 to the power of n minus 1 divided by 2x minus 1 whole to the power of n minus 1. Option D is none of the above. So the answer is B. Next one, find the nth order derivative of e to the power of 2x. Option A, x to the power of n into e to the power of 2x. Option B, 2 to the power of n minus 1 into e power 2x. Option C, x to the power of n minus 1 n into e power 2x. Option D is 2 to the power of n into e power 2x. The answer is D. The next one, that is a reference. The first book is G. K. Rangnath, the textbook of BSc Mathematics. And the next one is K.S. Chandrasekhar, that's engineering mathematics. So this is the end of this session. Thank you.